Hello everyone, I am Supriya from EC department. We are here to present a final year project on the topic Building a Dyslexia Detection Webapp with Boosting Algorithm and Flask. My team members are Saranya Sri and Shweta P. Our project supervisor is Shakunthala ma'am. Objective. The main objective of this project is to identify whether the person is affected by dyslexia or not and which stages they are in. So using boosting algorithm and Flask web application, we can able to identify the person is predicted by we can able to predict the person is affected by dyslexia or not. Here it aims to provide a hands-on experience in building a robust and effective tool for identifying dyslexia. Abstract. So I have already said that here we are using boosting algorithm. So especially XGBoost, it is used for developing the dyslexia detection model. So there are some process involved here. First is data collecting. It will collect the data and then it will pre-process the data by removing the unwanted data. And then it will train the model by splitting into the 80% into training the model and for 20% for the testing the model. And then finally, we are implementing the chosen algorithm by comparing the three algorithms. And then we are implementing into the Flask web application based on the accuracy value. Forward to Saraneshji.
Literature survey. These are some literature survey from past 5 years. Moving to next slide. Existing methods. Currently, there are various methods and frameworks available for building dyslexia detection web apps. Often integrating boosting algorithm like AdaBoost or XTBoost and Flask for web development. Typically, developers start by gathering a device data set of text samples, which includes both individuals with and without dyslexia. Pre-processing steps involves tokenizing text, removing irrelevant characters, and extracting features of dyslexia, such as word frequency and sentence lengths. Once the data is prepared, developers choose an appropriate boosting algorithm, train it on the dataset, and fine-tune it the optical performance. Then using Flask, they create a web app with routes to handle user input process test. Next slide. Proposed method. Begin by collecting a dataset of text samples from individual with or without dyslexia. Pre-process the text data by removing irrelevant characters and tokenization words. Extra um, dyslexia relevant features from the text, such as word frequency and sentences. Choose a suitable boosting algorithm like AdaBoost or XGBoost and labeled data. Develop the web app using Flask, setting up routes to handle the model prediction. Design a user-friendly interface with HTML templates, considering accessibility features like dyslexia-friendly fonts. Test the app thoroughly and deploy it on the server for public access. Next, forward to Shweta.
So this is the basic block diagram of a project. So the first step is data collection and then pre-processing, feature extraction, model selection, and then model evaluation, then deployment, and then we'll get the result. So in data collection, we'll get the following attributes like memory power, then local attributes, etc. So those attributes will be collected and will pre-process these attributes. So in majorly pre-processing is nothing but processing of collected data. So in under pre-processing, at first we'll collect the data and we'll clean the data, and then comes the sentence tokenization. So sentence tokenization is nothing but splitting of lengthy paras into sentences, and then word tokenization. Word tokenization is splitting of sentences, those sentences into words, and then stemming. Stemming is nothing but removal of ing and ed formats, and then converting them into their original format. Then comes the remantization. So remantization is nothing but the words which are taken, which are splitted, will be converted into present tense. And then feature extraction. Feature extraction is nothing but converting those words into zeros and ones form, that is binary format, so that the machine can understand them so clearly. So the next major step is model selection. So there are three methods. There are three methods or three types in which model selection can be done. So the first one is classification, then prediction, and then reinforcement. So in a project, we make use of classification, that is RF classification. So this RF classifier combines all the attributes that we are given, and it converts those attributes into a single result. And then it selects or finds the average of the outputs of all the attributes and the given output as affected or not by a numerical representation. It gives basically it gives a result in the form of zeros and ones, and it shows whether it also shows whether the person, in which stage the person is in. And the third phase is model evaluation. So in model evaluation, we make use of different algorithms. So here we compare when we compare different algorithms like RF algorithm, SPM algorithm, that is stochastic model, block model algorithm, random forest algorithm, and then cat boost, AdaBoost, and then other algorithms. We found that we came into a conclusion that RF algorithm and SPM algorithm gives an accuracy of 80 to 90% when compared to other algorithms. So here in this project, we have made use of RF algorithm and SPM algorithm. And then the last phase is evaluation and deployment. So here now we can see the simulation part.
Let me show this simulation part using Jupyter Notebook. So here we have used two algorithms. One is random forest algorithm and second is sklearn algorithm. So these are used for the classifier purpose. So let me run the program. These are the parameters, which is language, vocabulary, memory, speed, visual discrimination, audio discrimination, survey score. Based on these parameters, we'll get the output. These are the X, and Y is we are predicting the values, which is label. So it will show if there is a certain range. If there is a person is affected is between 0.1 to 0.5 means it is first stage, and then if it is 0.6 to 0.9 means that it will predict it as second stage. Copy paste this link. Now I've got the dyslexia prediction website page. So here I will give 0.1, and memory is I will give 0.2, and speed value will give like 0.3, 0.4, and audio description value I will give as like 0.2. Survey score I will give it as 0.3. Now let me give this predict option. So here I got first stage. So if it is in the range of 0.6 to 0.9, then it will predict as second stage. Let me show 0.6, and memory value as 0.8, and speed value is 0.9, and visual discrimination as 0.7, and audio discrimination I'll give it as 0.9, 0.6 as service score. So here I've given the random values. Now let me give the predict value. So here I got second stage. So this is how we have to find the person, whether the person is affected by dyslexia or not, and which stages they are in.
Listen, so using this web application, we'll be able to test whether the person is affected by dyslexia or not by providing the required attributes in the web page. So using this web application, we can not only predict whether the person is affected by dyslexia or not, but also we can find in which stage they are in.
And it is proud moment for the students such that the paper has been accepted in the second international conference on AI and ML applications held during March 15th to 16th in KS Rangasamy College of Technology, and they got a best paper award for the particular paper. Thank you. Thanks for watching.